something glorious. Unacademy Combat. Compete, crack, conquer.
A challenging GATE contest engineered to give you an experience like none other.
Where you put your knowledge to test
and battle it out with a test
To bring out the best in you, Unacademy Combat is the most competitive, gamified contest for GATE till date, with the best of the questions by best educators.
with detailed video solutions from top educators right after each contest.
Combat live with peers to get real-time rankings and win big.
Participate in every contest to improve your ratings.
Challenging contests every fortnight or alternate Sunday. Live ranking after every question. Big rewards for top rankers. Your passion to crack GATE deserves this. Your hard work towards your dream deserves this. Fuel your inner fire for the ultimate GATE challenge. Unacademy Combat. Register now.
Hello, good evening guys. How are you? Right, so we are back with the another interesting lecture on control system. We are studying this particular subject, and now very important topic that we are going to discuss today, that what is the effect of feedback on the performance of control system and why we are going towards the closed loop system and not with the open loop system. So today we are going to discuss that part. We will be looking into some problems also onto this feedback, and then we will be concluding the section. So after this particular section, today's lecture, from tomorrow onwards, that is from 8:30 to 10 p.m. we are going to discuss some of the problems on we are going to discuss the time response analysis. The time response analysis is a very important chapter of control system, right? So that we are going to start from tomorrow. So those who have not joined till this particular point, now they can understand the time response analysis in a very deeper sense, right guys? So we start with the today's topic, that is feedback, control system feedback, our feedback control systems. So in the previous in the very first lecture we discussed this particular point, that what is an open loop system. An open loop system is a system in which the feedback is not there. And what is a closed loop system? A system in which the feedback is there. So today we are going to discuss this point, that what is the type of feedback, what happens when we are using positive feedback, what happens when we are using negative feedback, what is the effect of feedback onto the system gain, system sensitivity, and system time constant, and system bandwidth. This thing we are going to discuss in today's lecture. So before we go further, let me introduce myself. My name is Rajat Kumar Jain. I have qualified GATE with AIR 212 in the year 2012 in the instrumentation stream. I have also qualified BARC test, OCES test, IBPS test, SSC JE test, and I am pursuing PhD in control system, and I am having 11 years of teaching experience and mentored more than 10,000 students. So till now I have taken the subjects like industrial instrumentation, electrical measurement, control systems, digital electronics, process control, optical instrumentation. I have already taken these subjects. So how guys you can connect with me and all other top educators of the country over Unacademy platform. You can use my code RAJAT11 for accessing the free live classes, RAJAT11, right? And you can do two kinds of subscription, the plus subscription and the iconic subscription. The plus subscription is covering live classes, crash courses, weekly tests, doubt solving sessions. The classes are both in English and Hindi. So the guys having language barrier problem, they are now separate out, right? The students who want to attend in English, they can attend in English. Those who want to attend in Hindi, they can attend in Hindi, right? Obviously, the technical terms in Hindi also will be delivered in English itself, right? There is no replacement for technical terms. So these are the benefits of plus subscription. The iconic subscription covers all the benefits of plus subscription, as well as some additional benefits. What are those additional benefits? So we are having personal coach, study planner, study booster session, personalized test analysis, dedicated doubt clearing instructors, preparatory study material, right? We can have these type of advantages. So what do we mean by personalized test analysis? This is very important. This is very important advantage we are having. What is our depth of study we have done, right? This can be checked using this personalized test analysis. Further, the study material can be used for lifelong. So this can be used for lifelong. Personal coach, one-on-one guidance, preparation strategy, right? That is a very important thing. Study planning, how you can plan, how you can schedule, right? How we have to start, how we have to finish, all those things. These are the very important benefits you are going to have in iconic subscription. Okay guys, so how we can connect? You have to simply write Unacademy Learning app in the Google Play Store, and you can install then the Unacademy Learning app, and you have to write your name, email number and mobile number to register with Unacademy, and you have to go under Manage Goal section. Under Manage Goal section, you can select variety of courses. Out of them, our key point courses GATE and ESE. Then you have to select on plus. Then you have to click on get subscription, so that you can see the available subscription plans. The available subscription plans are 12 months, 24 months, 18 months. We will be talking about those subscription plans very soon, right? So the subscription plans for GATE and ESE, right? 12 months, 24 months. Then you can apply the demo code over here, that is RAJAT11. Now note guys, this code is applicable for 10% discount till 28th February. After that, the 10% discount scheme is going to reduce to 5%. You can click on apply, then you can click on proceed to payment. Once you click on proceed to payment, payment summary will be available, and then you will be prompted to select any one of the online payment methods: debit card, credit card, EMI, UPI, wallets, net banking. The EMI option is a really good option which you can opt it, right? Because you can pay the entire amount in terms of fixed EMIs, and that is no cost EMIs. All right. Then GATE and ESE. So the subscription is available for both the courses, guys. Here it is very important thing. You are getting 1+1 benefit. You are giving fees for one course and taking the benefit of both the courses, GATE and ESE subscription. ESE and GATE both are the prestigious examinations. Those who have not attempted yet or those who have already attempted in their third year, now they can know the significance of this. Through ESE we can be selected in the UPSC services as an Indian engineer service, right? And through GATE we can do PhD, we can do MTech, we can go for foreign university MS, we can go for MBA, we can do the PSU job. So there are variety of options available after pursuing GATE, right? So again you can use my code Rajat11 and you can do any of the kind of subscription that you want to do. 12 months, 18 months and 24 months. These are the plans available for plus subscription. Okay, so I will suggest that if the students are in third year, they can go for 18 months or 12 months subscription. If they are in second year, they can go for 18 months or 24 months subscription, right? Because you are going to study the two topics, two courses, GATE and ESE. So that is a really advantageous thing for you all. Similarly, if we talk about Iconic subscription, the Iconic subscription is available only for 12 months and 24 months. It is not available for the 18 months. So again you can use my code RAJAT11 and you can get additional 10% discount. Guys, we have already started new batches from 15th of February 2021 and the batch is batch B, which is for the GATE 2022 and the branch is electrical engineering. You can learn from the top educators of the country. Some of them may be IITians, some of them holding GATE AIR1, some of them are IES, right? So you can have the benefit of all those faculties and you can learn from them after subscription only, and you can use the code RAJAT11, right? You can use the code RAJAT11. Then the Spark batch B for GATE 2022 for EC and EI, right? Again, these the batches are purely in English, so English batches only. This has also started from 15th of February. Then we are having a batch Verve for GATE 2023. So right now those who are in second year, right, they can join this 2023 batch, right? And again the same set of faculties over here which were there in batch B, right, for 2022. It has also started from 15th of February. So batch B Verve for GATE 2023 for electrical engineering, similarly for EC engineering, again the batches are in English only, right? So this is the benefit. And one more thing I would like to announce, that the ESE examination has been announced by UPSC and it is going to be conducted in the month of July 2021. Right, this year it is going to be conducted in the month of July. So for ESE general study paper, we have to study, we have to appear in the 5 papers in the mains, right now at my time it was 5 paper. Right now I don't have a pure idea, but maybe 3 papers. So one of the paper is general study, and for studying general study the batch has been started from 18th of February, which you can join. Again you can learn from the top educators of the country for entering into ESE. Okay, follow me on Unacademy at Unacademy, https unacademy.com, at RajatKJN1708. You can follow me here, and https tinYurl.com Unacademy GATE English. This is our Telegram channel. Guys, you can join this Telegram channel at the earliest for having all the updates regarding the lecture notes, right, regarding the questions, regarding the short videos, regarding the subscription benefits. All those things are available, regarding the quiz links. Right now this particular channel is having 5k subscribers. This channel is having 5k subscribers. So guys, you can join this particular channel. Okay, so control system lecture number 7. This is today our lecture number 7 and we are going to discuss today effect of feedback and feedback characteristics. This is our important topic today. So good evening once again everyone. Hope you are now taking interest, because the past 10 minutes I was involved in giving you the subscription details, right? So good evening everyone. Good evening Abhiram. Good evening Sunil, right? And those who are present, these names are in my mind because Vignesh, if he is there, right? They were attending the classes regularly. Okay, those who are there present and I am not taking their name, that means I am not. It is not that I am not welcoming them, right? Everybody is welcome in this particular lecture. You can learn control system, right? You can see all the previous lectures. You just all the links are available onto that Telegram channel, so you can just learn the entire control system using these videos, which are right now we are I am doing this live lectures, right? So lecture 7, effect of feedback and feedback characteristics. This is a really important thing, right? This is a really important thing. So let's start with the discussion, right? Types of feedback. So types of feedback, there are two types of feedback. What are the types of feedback? We are having positive feedback and negative feedback, no doubt about that. When we discussed control system, let's go in a flashback what we have discussed till now. So we started with control system definition, right? What is control system? Control system is a planned arrangement of elements to regulate some variable at some desired value. Control system is a planned arrangement of element to regulate some variable at some desired value. That is known as control system. Right now, the control system primarily having two divisions. One is called as open loop system and the other one is called as closed loop system. What is an open loop system? An open loop system is the one in which the controller is present, the plant is present, and the output is generated based on the reference input. This is the controller, this is plant. So the output is generated and the output is not dependent on some value of input, right? And output and input are compared. No feedback is given, right? No feedback is given. But in closed loop system, what happens in closed loop system? In closed loop system, we are going to give some feedback. We are going to give some feedback, right? We are going to give some feedback. This is plant, this is controller, right? And this is our sensor. So, but obviously we have discussed that at that point of time that open loop system are less accurate, open loop system are less costlier, open loop system are easy to design, they are less complex, open loop system are relatively faster, open loop system are relatively stable. So these things we have discussed on that particular time. And so as if the counterpart if we discuss the closed loop system characteristics, so due to this particular feedback, the accuracy of closed loop system increases. The closed loop system is more complex, more costlier, but they are more insensitive to disturbances, whereas the open loop system is more sensitive to disturbances, right? And closed loop system can neglect the effect of disturbances, whereas the open loop system cannot neglect the effect of disturbances. So this thing today we are going to discuss in detail, that what do we mean by feedback, what is the type of feedback, and how these type of feedback is going to affect the control system performance, right? The effect of stability, right? We can see this effect of stability. We can discuss that point of that thing also, effect of stability. All right. So open loop and closed loop, right? Controller. Now, what is the fundamental behind the open loop system? The open loop system is having actually the input. According to the input, the output should be corrected. Now the output is not tracked continuously, and in case of the closed loop system, the output is continuously tracked. What is the present value of output? It has been tracked with the help of the sensor and measurement system, and this present value is compared with the input value, right? And then some signal is generated so that this can be given to the controller, and then the controller is going to give some actuating signal. That actuating signal is going to be given to the actuator. Then actuator output is going to control the entire process or plant, right? So that is the complete process. So we discussed on that day that the open loop system are having certain advantages, so as they are having disadvantages. That's why the open loop systems are not preferred, and closed loop systems are having more advantages as compared to the open loop system. So the main two advantages are the accuracy in case of closed loop system increases, and the sensitivity towards disturbances. Sensitivity towards disturbances reduces. Sensitivity towards disturbances reduces. So now we are going to discuss all those things in detail, and after discussion, after this the theory, definitely we are going to cover some of the numericals. So if we talk about positive feedback, let's talk about positive feedback. The positive feedback adds the reference input RS and feedback output CS. Adds the reference input RS and feedback output BS, right? That should have been feedback output BS. The following figure shows the block diagram of positive feedback control system. This is the figure for positive feedback. That means we are simply taking this positive feedback, that is the plus value over here. So we have proved while we have done the block diagram reduction rule. So this can be easily proved that the CS by RS, that is the transfer function for such a control system, can be represented by 1 upon 1 minus GH. Now if we see the validity of this particular transfer function, this is only valid if 1 minus GH is less than 1. 1 minus GH is less than 1, right? Or we can say that, what we can say that 1 minus GH is less than 1. Sorry, not 1 minus GH is must be greater than 0. Sorry, 1 minus, the validity of this will be 1 minus GH must be greater than 0. That means 1 should be greater than GH or GH should be less than 1. The validity of this particular transfer function is only that the GH remains less than 1. If GH doesn't remain less than 1, then what will happen? If GH is equals to 1, then the CS by RS is going to become infinity. If GH is less than 1, then only this value is going to become positive, and this value is, if it is going to, if it is positive, it is less than 1, it is positive, then we are having some stable value of the output. Stable value of the output. Otherwise, this is not so. So we are going to discuss what is called as positive feedback. A positive feedback is normally called as a regenerative feedback. A positive feedback is called as a regenerative feedback, whereas a negative feedback is called as a degenerative feedback. So I suppose you people will understand that how this G upon 1 minus GH has been calculated. There is no need to discuss this thing again. Should I discuss this thing again? This is signal ES, right? This is BS, this is CS. This can be easily proved, right? So have you attended the previous lectures, dear all? Sylvia is there. Abhiram, Sylvia. Vignesh, Sunil. Is anybody is there? Hello? Alright, so then let's talk about the positive feedback. In a positive feedback control system, the set point and output values are added together by the controller as the feedback in phase with the input. Right? If you see that the set point value and the feedback output, these are added together. The error signal, if we talk about, this is RS plus BS. The error is additive. The error is additive, that means it will be in phase with the input. Right? It will be in phase in the input. Alright? Error is additive. The effect of positive, that is also called as regenerative, is to increase the system gain. That is, the overall gain with positive feedback applied will be greater than the gain without feedback. Right? Why this is so? See, this is why this is so. If GH remains less than 1, if GH remains less than 1, say 0.5, for an example, we are setting GH to be 0.5. So what will happen? 1 minus 0.5, that is going to become 0.5, and G will become now 2G. So if the earlier gain is G, then the new gain is 2G, right? So the gain has become double. So we are saying that, what we are saying that the effect of positive or regenerative feedback is to increase the system gain. That is, the overall gain with positive feedback applied will be greater than the gain without feedback. So this is like something that you people are studying very well, and somebody praises you that, yo, you have done it very well. So for an example, I am giving you certain question and you are instantly solving it. So I will be amazed to see that if you are solving the question in a second or in 10 seconds or in 30 seconds. So I will say, oh, very well, Sylvia, very well, Vignesh, or very well done by Sunil. Let's clap for them. So this feeling is going to increase your energy. That's a natural thing, right? If you are praising me that, sir, you are teaching very well, that is going to increase my energy. So that is a positive feedback. That is a positive feedback we are giving. So everything when we study in control system is related to our surroundings, right? And this thing I have said before also. So Whenever we are applying positive feedback, whether it is the human body system, whether it is the human environment, or whether it is a electronic environment, or it is a control environment, the meaning remains the same, that positive feedback is going to increase the system gain. But every time the system gain is not required so much high, right? That point is written over here. However, in electronic and control systems, too much praise and positive feedback can increase the system gain far too much, which would give rise to oscillatory circuit responses as it increases the magnitude of effective input signal. Since it is additive, the error signal is additive. What we are giving here, error signal is additive. So it is possible that it may introduce oscillations. An example of positive feedback system could be an electronic amplifier based on an operational amplifier or op-amp as shown in the next slide. So we are going to discuss what is exactly a positive feedback means, and how the positive feedback is going to increase the system gain, and what are the disadvantages if the system gain is increasing, right? So see here what is happening. This can be explained best by this particular diagram. What is happening here? See here what is happening. So see, this is the natural representation of operational amplifier. I suppose everybody is familiar with this. The operational amplifier is a versatile amplifier used to perform various operations. It is available in the form of IC, dual in line package. The most popular operational amplifier is MUA741 or LM324. The most popular op-amps these are, right? MUA is Fairchild and LM is National Semiconductor, right? They are the name of companies. MUA 741. So this op-amp IC is of 8-pin IC, and some of them are used for for giving the input and taking the output, and some of them are not used. That is a different point that can be discussed in the analog circuits, right? So how this op-amp work? The op-amp is having fundamental behavior that if we are applying some input, it is going to amplify that input by some gain, and it is going to produce some output, right? The input may be DC, the input may be AC. Op-amp is going to amplify both the inputs and is going to produce the output, but it is dependent. It is dependent on the value of the voltage which we are applying here. That is known as plus Vset and minus Vset. The output voltage will be dependent on this particular value, because in feedback the loop is restricted now, right? The output is restricted now. So what is happening? See here what is happening. We are taking a small amount of output and giving back to the same terminal. Now the next output will be dependent on this value as well as the present value of current, I in and IF. On these two values, the next output will be dependent. So that means we are taking some positive feedback, right? If the input voltage V in is positive, if the input voltage V in is positive, this V in is positive, the op-amp amplifies this positive signal and the output becomes more positive. That is naturally more obvious. If we are applying a positive voltage here, that will be amplified by the gain of the op-amp, and output voltage will be more positive. Some of this input voltage is returned back to the input by the feedback network. Thus the input voltage becomes more positive. Now input voltage becomes more positive, causing an even larger output voltage, and so on. And this particular process will carry forward. We have applied a positive voltage initially. Due to that, some output voltage is generated. Now that output voltage is going to be added here, right? Or that due to that the current will be added here. Due to the increase in output voltage, that current is going to be added over here. So the voltage across this point is going to be increased more, and it is going to produce further the more output voltage. So this cycle continues. This cycle continues, right? This voltage is further going to increase this voltage. Then further this voltage is going to increase this voltage. In this manner, there will come a point that this output voltage will be saturated to plus Vset. This output voltage will be saturated to plus Vset. Eventually, the output becomes saturated at its positively supply rate. That's what I said. Likewise, if the input voltage Vin is negative, the reverse happens and the op-amp saturates at its negative supply rate, right? Clearly, if input voltage is negative, so we have reversed the connection. For an example, we have reversed these connections, minus plus. So the input voltage has become now negative. So due to the negative voltage, the output is going to come negative. And if output is negative, then this negative feedback is added, so the voltage increases in the negative direction, and similarly there will come a point when the output will be saturated to minus Vset. What do we mean by plus Vset and what do we mean by minus Vset? Suppose if we talk about MUS741 or LM324, they can operate from plus 5 volt to plus 15 volt or minus 5 volt to minus 15 volt. That means they are requiring dual power supplies. The op amps are actually requiring plus minus 5 volt to plus minus 15 volt. They are requiring dual power supplies. So positive power supply is connected to plus Vset, one of the terminal of op amp, and negative power supply is connected to minus Vset, one of the another terminal of the op amp. Here likewise microprocessor, we don't have a ground signal. We don't have a ground signal because the op amp is actually comprising differential amplifier. The input component of op amp is having 4 different stages, and one of them is the differential amplifier. So due to that, the differential amplifier is actually requiring two supplies, and that's why the op amp is also having two supplies, right? So we are talking about this plus Vset and minus Vset. So some of these output voltage is written back to the input by feedback network. Thus input voltage becomes more positive, causing an even larger output voltage, and so on. Eventually the output becomes saturated at its positive rail. Okay, that we have already discussed. And if the input voltage increases in negative direction, so the op amp saturates at its negative supply rail. Then we can see that the positive feedback does not allow the circuit to function as an amplifier, as the output voltage quickly saturates to one supply rail or the other. Now it is not like an amplifier because the output voltage will be quickly saturating to some value, either plus Vset or minus Vset. That means this type of circuit can be utilized for making such a square kind of waveform. Normally, this positive feedback in op amp is utilized for comparative applications or comparator applications. That is again a different subject that we are not going to discuss here, how this can be used as a comparator. Okay. So, because with positive feedback loops, more leads to more and less leads to less. That means if we have applied the positive voltage, it is going to become more positive, and if we have applied negative voltage, then it is going to become more negative. That we are going to have. So more means to more leads to more, and less leads to less. That's a simple thing. Then if the loop gain is positive for any system, the transfer function will be AV upon G upon 1 minus GH. That we have already seen. The transfer function C by R, that is G upon 1 minus GH. Here it is representing as AV, that is the gain of the amplifier. That C by R is actually the gain of the amplifier. Alright. Note that if GH is 1, so if GH is 1, then it is going to become infinity. The system gain AV is infinity, and the circuit will start to self-oscillate. This behavior is good for oscillation, from oscillation point of view, right? And the oscillators are actually requiring positive feedback. But that is for oscillation, not for control system, right? For control system, we don't want any oscillation. Suppose I have applied a step input of this kind, then I require a step output of such a kind. After some time, it is going to give the step value. I require that. I don't want to have oscillations in my output based on the input signal what I have given. If normally I am applying the step input, I should get a step output, right? So I don't want oscillation. So in case of control system, it is not allowed to have GH equals to 1. And that's why if we have GH less than 1, then it is going to add on the gain. It is going to increase the gain, but the system stability is not maintained. That means it can produce the oscillations. No input signal is needed to maintain oscillations, which is useful if you want to make an oscillator. As I said, if you want to make an oscillator using this concept, then you can do that. But as far as the control system concepts are concerned, this cannot be done. Negative feedback. Let's talk about that. What is a negative feedback and how the negative feedback is different from positive feedback. Negative feedback reduces the error between the reference input RS and system output CS. Right, reference input RS and system output CS. The following figure shows the block diagram of negative feedback control system. This we have already seen, and we have proved that in block diagram reduction that its transfer function CS by RS can be given by G upon 1 plus GH. Its transfer function CS by RS can be given by G upon 1 plus GH. So now what will happen? See, if 1 plus for the validity of this transfer function, 1 plus GH has to be greater than 0, or GH has to be greater than -1. GH has to be greater than -1. If GH is equals to -1, then again the transfer function is going to become infinity, and that is going to result into oscillations, right? But if the GH is greater than -1, right, greater than -1, then the value of this particular value is going to remain positive always. And for larger values of GH greater than 1, the value of the CS by RS is totally dependent on the feedback parameter. That can be simplified like this, right? G upon 1 plus GH, and since GH is much larger than 1, so we can write G upon GH, and GH cancelled is dependent on H, that is the feedback path parameter is dependent only on feedback path parameter. That means how effectively you are tracking the output. The meaning of this thing is what? How effectively you are tracking the output. Whatever output you are measuring with some type of sensors, some type of transducers, you are measuring output. You are going to do that, right? For an example, when we are driving bike, right? We as a human being driving a bike or driving a vehicle, right? What are the senses which are acting around us? Our eyes are working at that time. Our ears are working at that time, right? Our touch sensing is working at that time. Whenever we are driving, right? We are driving. If we suppose we are moving the steering, our touch sensing is working onto that time. So these are the things which are continuously working so that we can guide ourselves to drive safely. If these things are not proper, so the person who is having hearing disability, the person who is having this visible disability, then they are not supposed to drive the bike, right? Because their senses are not working properly. That's why we are saying that if the product GH is much higher than 1, then the entire transfer function will be solely dependent on H. That is the feedback path parameter, that is the sensor or measurement system. In a negative, likewise we discuss the theory of positive feedback. Here also we can discuss the theory of negative feedback. In a negative feedback control system, the set point and output values are subtracted from each other as the feedback is out of phase. The feedback is out of phase with the original input. Right, now see that how it is out of phase with the original input. See here, since it is negative, CS is some value we are getting over here. CS, say we are having a unity feedback over here, so we are going to have CS, but it is minus CS we are going to have. So what the error signal we are going to have? It is RS minus CS. We are going to have this type of error signal, this error signal. Now there can be two values of the error signal depending on the value of RS. If the value of RS is more than CS, it is positive error. If the value of RS is less than CS, it is negative error. The positive error is going to increase the controlled variable. The negative error is going to increase decrease the controlled variable. So eventually this thing is doing a realistic control. A realistic control. Let's understand this with another practical example. The practical example is suppose we are doing the level control. We are doing the level control. And the level control mechanism is done with the help of some operator. The level has to be maintained up to certain height h. For that we are using the side glass method or side glass tube for detecting the level. There is some operator over there for operating this particular valve, and the operator is continuously observing the value of the level in this particular side glass. If the level is full, then what the operator is supposed to do, even if the flow is running, continuously the flow is running. So the operator is supposed to move this valve. Operator is supposed to open this valve. This operator is opening this valve. That means it is actually the resistance, and this Q0, it is the outflow rate. So outflow rate is going to be increased. Right, on increasing the value of height, the outflow rate is going to increase. However, the controlled variable, due to the controlled variable, the outflow is going to increase. That means what? The error is generated in the negative direction. This has to be shut off when the level is not reached. At that time, the error is positive, right? So when the error is positive, this should be stopped, and if the error is negative, then this should be opened, right? So that is the thing we can understand with this negative feedback, with the negative feedback system. One another example, for an example, this is a temperature control system. We are having a plant that is AC, and we are having a controller over here, right? We are having a controller over here, and we are setting the temperature through remotes at 25 degrees C. So if the current temperature of room is 30 degrees C, then the signal that is going to be generated is minus 5 degrees C. Signal that is going to be generated as minus 5 degrees C, the error signal, it will be given to the controller. Then controller will going to decrease the condensation value so that the temperature can be cooled down. Sorry, increase the temperature, increase the condensation so that the temperature can be cooled down. So here now the controller, due to increase in this particular value, the controller action is increasing, the condensation is increasing. So that is known as the direct action. That is known as the positive value, and this is known as the negative value, right? That we can understand with this particular kind of analogy for the temperature system as well as the level control system. The level control system and the temperature control system are one of the example for the positive error and the negative error. So when we are talking about that, if the control system is having negative feedback, that means the response or the error signal which is going to be applied to the controller is going to become degenerative. That's why the negative feedback is said to be degenerative. That means the response from the comparator is not additive, it is subtractive. So it is going to become less. Right? The effect of negative or degenerative feedback is to reduce the gain. Now that is the thing. That is quite simple here. Quite simple. Suppose if GH is more than 1 or more than minus 1, then the normal gain of the open loop control system has been reduced by a factor 1 upon 1 plus GH. It has been reduced by 1 upon 1 plus GH. So the negative feedback is going to reduce the gain. So for that we will be requiring the circuits like controllers or compensators. If the gain is reduced, then we will be requiring the circuits like controllers and compensators. That's why we were saying that the design of the closed loop system is complicated or complex, because it is requiring more than 2 elements or more than 3 elements. Now controllers and compensators will be required for compensating the change in gain and change in phase. Change in gain and change in phase are occurring, right? Because negative feedback produces stable circuit response, improves stability and increases the operating bandwidth of a given system. The majority of all control and feedback system is degenerative, reducing the effect of gain. An example of negative feedback system is an electronic amplifier based on an operational amplifier as shown in the next figure. Now you will ask me this question, sir, while we discussed the open loop and closed loop system, you said that the closed loop system are less stable. Then here we are saying that the closed loop system are more stable. So the thing is that it is not only the thing is that this degenerative feedback is always going to stabilize the system. It is going to introduce the instability in the sense that the oscillations will also be increased if the gain is reduces by too much value. Then both the possibilities are there. In the positive feedback, the gain was increasing by too much value. In the negative feedback, the gain is reducing by too much value. So both these cases, the upper limit and the lower limit is going to reduce the oscillation. Both these cases are going to reduce the oscillations. Alright. So guys, we can say that the feedback is actually relatively decreasing the stability, not the exact stability. Sometime not absolute stability. Sometime what happens, due to increase in the gain or due to decrease in the gain, the oscillations are introduced in the system, and the oscillations are not desirable. That's why we say that the closed loop system is relatively less stable. There is no case of oscillation in case of a open loop system. For an example, you are pressing a switch of some electric appliance. You are pressing the switch. As soon as you press the switch is the controller of that particular appliance, which is controlling the power supply. So as soon as you press the switch, the controller, your appliance gets switched on, and when you close the switch, your appliance gets switched off. Now what you don't want? You don't want that when you press the switch, your supply automatically, your appliance automatically switches off and switches on. That will not be a good condition for you. So that's what we say, that in the open loop control system is, it normally happens whatever we have given as the input, the output is going to be according to that, and it is going to remain until it is not changed further. It is going to remain until it will not change further. Like we take the example of washing machine, or we are ironing some cloth. So if we are ironing some cloth, that means it is an open loop control system, right? It is an open loop control system. What is happening over there? We are ironing according to our perception. Once the ironing is done, we are pressing the switch off. Right? So automatically the temperature of that thermostat which is present in the iron is going to set the temperature, and accordingly it is going to cut off the value of power. That's why it is called as automatic iron. It is only cutting off the power. It is not doing any other thing in that particular iron system, right? So if we talk about the stability point, that stability point simply deals with the introduction of oscillation into the system which are not desirable as far as the model control system or the reliable control system is concerned. So now that is the example of a negative feedback system. See here, the output is now given to the negative terminal of operational amplifier, the same amplifier, right? Plus V set, minus V set. Now the positive terminal has been connected to ground. In the earlier case, the negative terminal was connected to ground. Now we are applying, now we are applying the positive voltage, and the output is measured. So if the input voltage Vin is positive, the op-amp amplifies this positive signal, but because it's connected to inverting input of amplifier, the output becomes more negative, right? The output becomes more negative. Why? Because we know that the general equation of this operational amplifier V out for this inverting configuration, V out is what? Minus RF by R1 into V in. So if you going on increasing the V in positive direction, your V out is going to become negative, and if you are going to increase the V out V in negative direction, right? V in negative direction you are going to increase, your V out is going to become positive. So in this case what happens? Less more to add, and more add to less, right? It is like that. Some of this output voltage is returned back to input by feedback network RF. That is obvious, that is quite visible from the diagram itself. Some of this voltage is returned back to the input by the feedback network of RF. Thus the input voltage is reduced by a negative feedback signal, causing an even smaller output voltage, and so on, right? The input voltage is reduced by negative feedback signal, causing an even smaller output voltage, and so on. For an example, very simple example we can take. Suppose you have applied a 1 volt over here. RF is having a value of 10 kilo ohm. RF1 is having a value of 1 kilo ohm. What output you are going to get? You are going to get minus 10. 1 volt is much greater than minus 10. Your output has been reduced. Your output has been reduced because of the factor. Why? What is the factor? That because of the factor of the negative feedback. But the thing is that this negative sign is actually telling that the phase inversion. This negative sign is actually telling the phase inversion. Otherwise it is behaving like an amplifier. The amplifier which is having a gain of 10. This is the phase inversion this negative sign is telling us, right? Likewise, if input voltage Vin, eventually the output will settle down and become established at value determined by the gain ratio of RF by Rn, right? Likewise, if the input voltage Vin is negative, the reverse happens and the op-amp's output becomes positive, which adds to negative input signal. Then we can see the negative feedback allows the circuit to function as an amplifier. It is functioning like an amplifier so long as the output is within the saturation limits. So we can say that, the output voltage is stabilized and controlled by the feedback, because with negative feedback loops, more leads to less and less leads to more. That is the thing we have already discussed. So in case of negative feedback is called as degenerative feedback. It is decreasing the gain, but it is introducing more stability as compared to the positive feedback. It is decreasing the gain, but it is introducing more stability as compared to the positive feedback, right? See here, the use of negative feedback in amplifier and process control systems. Already taken the name. Process control system, that means the control system. The use of negative feedback in amplifier and process control systems is widespread because, as a rule, negative feedback systems are more stable than positive feedback systems. And a negative feedback system is said to be stable if it does not oscillate by itself at any frequency except for a given circuit condition. Right? Positive feedback system can oscillate for any frequency. However, the negative feedback system doesn't oscillate for particular frequency only. It can oscillate. Another advantage is that negative feedback also makes control system more immune to random variation in component values and inputs. By random variation we mean the disturbances. The random variation we mean the disturbances. Let's talk about in detail about these disturbances. Let's take an example of a temperature control system, which is an automatic control system, or we can say that the feedback control system, right? This temperature control system is involving some elements. So say the RS is reference temperature input. This is the controller which we are having. Then we are having the plant, that is our air conditioner, and the controlled output, that is our temperature CS, temperature of room or temperature of hall in which this particular control system is installed. And this is our sensor or measurement circuit or measurement system, which is continuously tracking this output. It is continuously tracking, continuously monitoring this output. Now what happens? If you are pressing some button through remote 25 degrees C, right? You are pressing the button, it will check for the current temperature. If it is current temperature is 25 degrees C, no action needs to be taken. The controller will function as it is. The complete loop will function as it is. But if the current temperature increases, say it becomes now 35 degrees C. So according to the 25 degrees C, we are now receiving 35 degrees C. That means the minus 10 degrees C is given to the controller. That means the controller output is going to be increased so that the condensation can be increased, so that the temperature of the room can be brought down to minus 10. So what we want, we don't want that. Meanwhile, it is done. Once the signal is given, the feedback has been processed, the error signal has been generated. Meanwhile, again, the new output should not come. And if it is not new output, then any other random variable, random noise or random disturbance should not occur. What can be the disturbance? The disturbance can be somebody is switching on the fan at a full speed. The disturbance can be somebody is continuously opening the door. Somebody is continuously opening the window. And moreover, the density of the people inside that room or hall increases suddenly. So these are called as disturbances. So if we are using the negative feedback, then the negative feedback is going to cope up with all disturbances. Rather, feedback is going to cope up with all disturbances and going to produce the actual output. That's why sometimes when we are saying that due to feedback the gain is reducing, no problem. The gain reduction is not a big problem. This can be overcome by introduction of a controller or a compensator. The gain can be increased significantly. So there is not a problem at all, right, of reducing gain. But the problem is that if the disturbances are continuously occurring, then our system should be capable of measuring those disturbances, and not only measuring those disturbances, the system should be capable of removing the error which is occurring due to those disturbances. So for example, somebody is continuously opening the door and closing the door again and again. So the sensor system or measurement system should track this output very effectively. Then only the exact value of the feedback signal is maintained and exact value of actuating signal can be maintained. Once the reference value has been given, the reference value is set, right? So if our sensor or measurement system is not measuring the value perfectly, then our output is going to be affected. Our output is going to be affected due to disturbances, and this is likely going to happen more in case of open loop system and less in case of closed loop system. That's why the closed loop system are preferable as compared to open loop system. Okay guys, So any doubt to anyone till now? We have almost discussed regarding the positive feedback and negative feedback. Now we move towards the effect of feedback from the next slide. Any doubt to anyone? Effect of feedback, right? Effect of feedback on overall gain. Now let's talk about this. Effect of feedback on overall gain. So the open loop transfer function was G. The closed loop transfer function was G upon 1 plus GH. So the open loop transfer function has been reduced by a factor 1 upon 1 plus GH. That is effect of feedback. Effect of feedback on overall gain. From transfer function we can say that the overall gain of negative feedback closed loop system is the ratio of G and 1 plus GH. So the overall gain may increase or decrease depending on the value of 1 plus GH. Right, it is decreasing because we are assuming that the value of GH we are going to take more than -1. So it is decreasing. Right. If the value of 1 plus GH is less than 1, the overall gain increases. In this case, GH value is negative because the gain of the feedback path is negative. If the value of 1 plus GH is greater than 1, then the overall gain decreases. In this case, GH value is positive because the gain of feedback path is positive. Right? In general, excuse me, G and H are functions of frequency. So the feedback will increase the overall gain of the system in one frequency range and decrease in other frequency range. That is a really true thing, right? The value of G and H are the functions of frequency. Why they are functions of frequency? Because we are writing what we are writing. CS by RS is equals to GS by 1 plus GSHS. So the value of GS is something like 1 upon S plus 2. It is a function of frequency. If the frequency increases, the value of GS increases. GS decreases. If the value of GS decreases, then definitely the overall transfer function is going to reduce. The value of GS decreases. Right. Similarly, if the value of frequency decreases, then the value of GS is increases and overall transfer function is going to increase. So that's why we are saying that in general, G and H are functions of frequency. So the feedback will increase the overall gain of the system in one frequency range and decrease in the other frequency range. So we have to design the feedback. We have to design the control system in such a manner that the control system must operate for a particular range of frequency. That's why we are deciding the bandwidth of the control system. In that particular range of frequency, it should behave like a flat frequency response type of system. That means for that particular frequency range, it should produce a finite output, and after certain frequency, that is known as cutoff frequency, the output may decrease by some value. That is a likely possibility. So the feedback, that's why we are saying that the control systems are normally, the open loop systems are normally more stable, relatively more stable, and closed loop systems are relatively less stable, because the closed loop systems are going to increase the gain beyond certain limits, and they may going to decrease the gain beyond certain limits, and that's why due to this increase and decrease, the oscillations are produced in the system, and oscillations are intolerable. Effect of feedback on sensitivity. Now let's discuss this effect of feedback on sensitivity in a deeper sense. What do we mean by sensitivity, and how the sensitivity is calculated? What is sensitivity, and what is the sensitivity towards the disturbances? Right, this thing we can discuss in this particular section. Sensitivity of overall gain of negative feedback closed loop system T to the variation in open loop gain G is defined as STG upon del T by T upon del G by G, percentage change in T upon percentage change in G. Right. So actually it is defined like that. STK. What is STK? Del T by T upon del K by K. It is like that. STK. Now K can be anything. Your K can be anything. This K can be forward path gain. The K can be feedback path gain. This is known as sensitivity. So the sensitivity should be low. The sensitivity should be low. If the sensitivity is not low towards this variation in the parameters, then the output is going to change. So let's take an example of open loop system. Let's discuss first of all the open loop system. So this is our open loop system. GS, RS and CS. For open loop system, the value of transfer function Ts is equals to GS itself. Right. So let's define the sensitivity. Sensitivity STG del T by T upon del G by G. This can be written as G by T into del T by del G. Right. Now for open loop system, overall transfer function T is equal to G. Hence, STG is equal to G by G into del G by del G. That is going to result into 1. That means STG sensitivity due to gain is 100%. What is it is? It is 100%. That means the open loop system is 100% sensitive to variations in GS. So that means what? If your GS changes by a little bit, that means your CS is going to change by a little bit. But it should not happen. It should not happen. Right? GS is changing. GS is changing due to external effects, external factors. That is the cause for GS changing. But due to change in GS, the output should not change. But it is happening. It has been proved mathematically that if you are going to change the value of G so as your sensitivity is going to become 100%. Now your sensitivity is 100%. That means you are going to change the value of G. Your net output is also going to change. C is also going to change. Right, that is quite obvious. That is quite obvious. So, sensitivity due to gain on open loop system. Now, let's talk about the closed loop system. The same thing. If we talk about the closed loop system. So, what is our closed loop system? This is our closed loop system. HS, GS, CS, minus and RS. Right. So what is our CS by RS? For the closed loop system, the CS by RS is GS upon 1 plus GSHS. This is our TS. Right. So our sensitivity STG will be given by del T by T upon del G by G, or it is G by T into del by del G of T. And T can be written as G by T del by del G of this whole factor GS upon 1 plus GSHS. Right. So let's differentiate it. Let's derive it. If we derive it, what will happen? 1 plus GSHS into 1 minus partial derivation, right? GS into del by del G of 1 plus GSHS upon 1 plus GSHS the whole square, and this thing will be multiplied by G by T. Let's take this, continue this. We can continue this, right? So STG G by T, that means GS upon 1 plus GSHS multiplied by this whole factor. So when we solve this, it is going to become 1 plus GSHS minus GS minus sorry, that is going to become HS minus GSHS. So GSHS and GSHS is going to cancel out, only 1. What is resulting? Only 1. So in the numerator we are going to have 1. In the denominator we are going to have what? 1 plus GSHS the whole square. 1 plus GSHS the whole square. So finally we are having GS cancel out, GS will cancel out this one. So finally we are having STG 1 upon 1 plus GSHS. Guys, 1 upon 1 plus GSHS. That means our sensitivity for the gain has been reduced by a factor 1 upon 1 plus GSHS. Although we were saying that the gain has been reduced by the same factor, the sensitivity has also reduced by the same factor. That means even if your GS is changing by some quantity, your output is not going to change. Your output is not going to change. That is known as sensitivity towards the GS. That is known as sensitivity towards the GS. Now let's take another example. The sensitivity with respect to feedback. STH. What will be that? Del T by T upon del H by H. Right. Suppose the feedback path is affected by the disturbance. Right. We have only talked about the forward path. This is the forward path. And this is the feedback path. So suppose the feedback path is affected by the disturbance. Then what will happen? The feedback path is affected by the disturbance. So let's talk about that. dt by dh. So we can calculate this as h upon t. dt by dh. And this can be written as h upon gs upon 1 plus gshs multiplied by dh of this whole function gs upon 1 plus gshs. That is the partial derivation of this entire function with respect to h. Okay, so let's do that. What is going to remain finally? H upon gs upon 1 plus gshs into new denominator whole square 1 plus gshs the whole square and 1 plus gshs d by dh of gs minus gs d by dh of 1 plus gshs. Alright, so what will be the solution finally? H upon gs upon 1 plus gshs into, now this term is going to vanish because d by dh, there is nothing like that. This term is going to vanish. We are going to have a minus sign, right? Minus gs, and the result of this term is hs. Minus gs hs, right? H of s. And we are having here 1 plus gs into hs the whole square. So we are going to have what? With respect to h, gs, it is going to cancel out. 1 plus gs and 1 plus gs hs is going to cancel out. Right? Something we are going to miss it. Are we missing something in this particular differentiation? Nothing. Right? Everything is correct. D upon dh with respect to h, the derivation of this gs is going to become vanish, going to zero, going to become 0. That's why it is 0, the entire equation. And gs into this 1 plus gs hs. So that is resulting into that is resulting into gs only. Sorry. That is resulting into gs only. That's why it is gs into gs. GS into GS. That's why I said that we are missing something. GS into GS. Let me clear this and write it again. So this is now GS into GS, right? GS into GS. The derivation has to be done with respect to H. That's why the answer will be GS. GS, HS. Alright. So GS, and this is GS. So one of the GS is going to cancel out. This square term is going to cancel out. Finally, we are going to have GSHS upon 1 plus GSHS. Earlier, due to the forward block, we were having the sensitivity as 1 upon 1 plus GSHS. Now, due to feedback path variation, the sensitivity has been minus GSHS upon 1 plus GSHS. That means it is now dependent on the value of the feedback what we are providing. If the feedback is increasing, the sensitivity is increasing. If the feedback is decreasing, the sensitivity is decreasing. Right? The sensitivity is decreasing. Or the inverse manner it is actually going. If the feedback is negative, the sensitivity is going to become positive. If the feedback is positive, the sensitivity is going to become negative. That means if we are decreasing the feedback, the sensitivity decreasing means minus, the sensitivity is going to increase towards the disturbances. And if we are increasing the feedback, the sensitivity is going to increase towards the disturbances. Right, that's what we can understand from this. So when we are discussing about the sensitivity with respect to H, the sensitivity increases due to insertion of the or it is actually dependent on the value of the H's. It is actually dependent on the value of H's. That is the effect of sensitivity, effect of feedback onto the sensitivity. So we got the sensitivity of overall gain of closed loop control system as the reciprocal of 1 plus GH. So sensitivity may increase or decrease depending on the value of 1 plus GH. If the value of 1 plus GH is less than 1, then sensitivity increases. In this case, GH value Sami Khan is saying that, sir, please make a special class topic wise day list, since we have lot of maybe thousands of videos in special class, so we are not able to find the specific topic. Please. Okay, Sami, we will be publishing that list also of our schedule, right? But the thing is, what happens sometimes due to some emergency, the schedule may not be may not be conducted on time. So it's a tentative posting of the topic has been done in advance. We post our topic in advance, and you can select among them what topic you are going to discuss. So this particular topic I have posted way back on Friday, that I am going to take this topic on Sunday. So you can select. Similarly, I am going to take tomorrow the transient response analysis, the first class of transient response analysis. So you can join that particular class if you want to join. So this thumbnail is active in our Unacademy GATE English channel of YouTube. So you can join that particular channel and you can get update about those all lectures. Right? It is not in my hand to display the entire list of the videos. That is in the hand of backend team. And I will forward your request to display the entire list to the student. Okay. Thank you very much for your feedback. Let's continue. If you are having any doubt in this feedback, you can just ask me right now, and you can be in the lecture so that we can do some numericals. At the end of this particular lecture, we are going to do some numericals. If the value of 1 plus GH is less than 1, the sensitivity increases. In this case, GH value is negative because the gain of feedback path is negative. That means it is talking about the positive feedback. It is talking about the positive feedback. And this line is talking about negative feedback. Okay. I will forward your request, Sami, to the backend team for doing that. All right. So in general, G and H are functions of frequency. So feedback will increase the sensitivity of the system gain in one frequency range and decrease in the other frequency range. Therefore, we have to choose the value of GH in such a way that the system is insensitive or less sensitive to parameter variations. That's what we have discussed here. Right now, we have discussed that if we are increasing the value of G in case of open loop system, if case of open loop system the value of G is affected, then the overall transfer function is going to affected because the sensitivity towards G is 100%. In case of closed loop system, the sensitivity is not 100% but dependent on the value of G and H. Right, so definitely we have to select the G and H values in a bounded frequency range. So that the sensitivity can be decreased towards the parameter variation, towards the disturbances. Okay. So the sensitivity towards G is less, sensitivity towards H is more as compared to sensitivity towards G because it is increased by the factor GSHS. If the factor GSHS increases, the sensitivity to feedback path parameter is more. Here from this we can conclude, the important point that we want to conclude here, the control system is more sensitive. The control system is more sensitive to feedback path variations, feedback path parameter variations. Feedback path parameter variations. That is a very important note that we can remember from this, right? They are less sensitive to forward path parameter variation. The closed loop systems actually we are talking about, but more sensitive to feedback path parameter variations. Effect of feedback on stability. Now let's talk about this. A system is said to be stable if its output is under control. This is the natural definition of stability, BIBO stability. This thing we are going to cover in our stability topic on next Friday. Okay, Sami, you can have this entire list of topics. Probably I will recommend the backend team to generate all my thumbnails so that you can have the entire list of this topic. Or I can tell you right now here what topics we are going to cover in the upcoming 5 days. In the first 3 days on Monday, Tuesday and Wednesday, I am going to cover transient analysis. On Thursday, I am going to cover steady state analysis. And on Friday, I am going to cover the stability. On Friday and Saturday both, right? I am going to cover this stability. And then from 1 March onwards, Sunday, I will not be able to take class on Sunday, 28th of February. And from 1 March onward, I am going to continue with the root locus. So on Friday and Saturday, stability, that will be our concern. Stability using Ruth-Hurwitz's criteria, stability basics. This is the entire week schedule. Semi, for you only I am telling this. Okay, so you can attend if you want any of these topics. On Monday, I am going to discuss first order systems. On Tuesday, I am going to discuss second order systems. On Wednesday, I am going to discuss specifications, dominant pole zero concept. This thing I am going to cover in these particular days. And on the Thursday, I am going to discuss the steady state error, the static error coefficients and their calculation. And on Friday, stability, BIBO stability, unstability, location of pole and zero, Ruth criteria, Hurwitz criteria, Ruth-Hurwitz criteria, and the basics of Ruth-Hurwitz criteria. On Saturday, we are going to discuss special cases of Ruth-Hurwitz criteria and application of Ruth-Hurwitz criteria. Okay, these are the things. This is the plan. This is the plan for this particular month. Okay, Semi, for you, I have displayed the list. So, a system is said to be stable if its output is under control. That is known as BIBO stability. Bounded input, bounded output. Otherwise, it is said to be unstable. If it is not bounded input, bounded output, then it is unstable system. That means for bounded input, we are getting unbounded output. For when we are removing the input, the output is not coming back to zero. That is known as unbounded output or bounded BIBO instability. So in equation 2, what is that equation 2? That is 1 of G upon 1 plus GH. Right? It is talking about that equation. If the denominator value is 0, 1 plus GH is equal to 0, then GH is going to become minus 1. Then the output of the control system will be infinite, so the control system becomes unstable. So the gain has to be less than minus 1. Gain has to be less than minus 1. The gain product has to be less than minus 1. Oh, sorry, more than minus 1. Alright. Therefore, we have to properly choose the feedback in order to make the control system stable. Let's understand this with a bigger sense. Okay. Suppose we are talking about an open loop system. 1 upon S plus 2. We are applying some finite input to it. Say we are applying a finite input, an impulse input to it. Right? If we are applying an impulse input to it, that means it's impulse input del t we are applying. And we want to calculate the output of the system. So what will be the output of the system for such a open loop system? Right? Output of the system CT is L inverse of CS into R of S. That is L inverse of 1 upon S plus 2 into 1. And L inverse 1 upon S plus 2 plus 1 is e to the power minus 2t. E to the power minus 2t. Probably you will understand this, how I have done this. Let's go into the bigger picture once again. I am just erasing all those things. It is RS, it is CS, hence our CS is equals to GS into RS. GS is given as 1 upon S plus 2, RS is given as 1, so our CS is equals to 1 upon S plus 2. What will be CT? CT is Laplace inverse of CS. That is Laplace inverse of 1 upon S plus 2. That is e to the power minus 2t. So if I want to plot e to the power minus 2t, then that will be CT t e to the power 0 is starting from 1 and e to the when we increase the value of t, right, it is going to decrease like this factor. It is going to decrease like this, and this is dependent. This slope is dependent on the value of this pole, minus 2t. Right, now I take the example of the closed loop system. For an example, I am taking the closed loop system. So the closed loop system is now like that. We are having K and 1 upon S plus 2. And suppose we are considering the unity feedback system, CS. And this is RS. So for closed loop system, what we will be having? CS by RS is equal to 1 plus K by S plus 2. That is equal to S plus 2 plus K. S plus 2 plus K. Now suppose we are selecting the value of K to be 10, or we are selecting the value so for an example, we are selecting the value of K to be 10. So what will happen now? CS by RS will become what? S plus wait, some mistake I have done. In this case, we are having this, right? So K upon S plus 2 upon 1 plus K upon S plus 2. This we are going to have. So we will be having CS by RS as K upon S plus 2 plus K. s plus 2 plus k. Now I select for an example k value to be 10. Suppose I am selecting that. So what will be our CS by RS? Our CS by RS will be 10 upon s plus 12. And now CS is equals to 10 upon s plus 12 into R of s. 10 upon s plus 12 into R of s. Right? So CT will be 10 upon s plus 12 into 1, because I am selecting RS to be the delta t. The delta t, that means the L of delta t. That means it is the unit impulse function, that is 1. RS equals to 1. So 10 upon s plus 12, that will be my final output, L inverse of that. So what will be L inverse of that? 10 into e to the power 12t. Now you compare this response with the earlier response what we have obtained in case of open loop system. Now if I put t equals to 0, I am going to get a value called 10 over here. And in the earlier case, when I was having only this open loop system, I was getting the value as 1. So due to this system parameter k, the value of the output has been increased. Now at the same time, what has happened? E to the power minus 12t. So for t equals to 1, what is the value of the output? Let's compare these two things. For t equals to 1, in this case, for t equals to 1, what is the value of output? E to the power minus 2 into 1. E to the power minus 2, 0.135. 0.135. Right? And for this, t equals to minus 1. E to the power minus 12. So it is 6.14 into 10 to the power minus 6. 6.14 into 10 to the power minus 6. That means it has almost reduced in a second. It has almost reduced to 0. That means the system has become relatively more stable due to addition of the feedback. But the thing is, it is actually dependent on the value of k, what you are selecting, and the value of the k should not affect the sensitivity. So all these things should be matched, because as some other factor, if we talk about it, for some other factors, the system may become slow if we are going to increase the value of k too much, and for certain cases the system may become oscillatory if we are going to increase the value of k. So that depend on the type of system, on the order of the system, right? What type of order, what is the system on which we are working? So the stability is affected by the feedback. There is no doubt. It is affected by the feedback. On properly choosing the parameter value, the stability concerns can be adjusted. As far as the previous discussion is concerned, normally the feedback is introducing the oscillations due to upper and lower limits. However, the oscillations can be prevented if we are working in the saturation limit of the components. Okay. Effect of feedback on time constant. Now let's talk about the effect of feedback on time constant. Let's take the same example. We are taking our GS as open loop system 1 upon s plus 2. Its time constant is, if I am converting into time constant format, its time constant will be 1 plus 1 by 2s. This 2 is taken as common, 1 by 2, right? So its time constant is t. I mean, if we compare this with the standard representation, so the time constant of the open loop system TOL is 1 by 2, that is 0.5. Now I convert this into closed loop system. So closed loop system, that is CS by RS, that is equal to GS upon 1 plus GS, considering that it is having the unity feedback. So what will be that? 1 upon s plus 2 upon 1 upon 1 plus 1 upon s plus 2. So it has now become what? It has now become 1 upon s plus 3, and if I solve it, then it will become 1 by 3, 1 plus 1 by 3s. So if I find out its time constant value t closed loop, the time constant value is now what? The time constant value is now 1 by 3. 1 by 3 is 0.33. 1 by 3 is 0.33. So we can say that due to the feedback, the time constant decreases. Due to feedback, the time constant decreases. Due to feedback, the time constant decreases. Right? It's a simple thing we have proved. The open loop time constant, comparing this with 1 upon 1 plus st, and the closed loop time constant. That is again 1 upon 1 plus st. If I am comparing this with t, so t comes to be 1 by 3. 1 by 3 is 0.33. And eventually we have proved this with this particular example. What we have proved earlier, it was taking more time to settle to infinity. To 0, and here it is taking less time to settle to 0, right? So the time constant is increased. That's why the system response has become fast. No doubt about that. The system response has become fast. Now again, you will have a question. You will be having a question. Sir, you have said that the open loop systems are relatively faster as compared to the closed loop system. So now you are saying that the time constant decreases. So if the time constant decreases, then the system becomes faster. So isn't it a contradictory thing? So definitely it is not a contradictory thing. My friends, what is happening here? We are talking about the normal operation of the system. Right. So the normal operation of the system of the control of the open loop system is faster as compared to the closed loop, because the closed loop system is actually comparing the output, and in comparison it will take some time. That's why we are saying that for the normal routine operation, the open loop system are faster as compared to closed loop system. And due to the feedback, the time constant is decreasing. That means the relative performance of the control system with respect to the previous case, has been faster. That can be understood. Effect of feedback on bandwidth. Let's take the same case. Of the same type of system. Suppose we are having this system. So our input RS, GS, and CS, and the value of GS is 1 upon S plus 2. I am considering with the same example. 1 upon S plus 2. So what is the bandwidth of this particular system? Bandwidth is the value of the frequency at which the magnitude of the system becomes 1 by root 2. Let's calculate this bandwidth. Magnitude of this particular system will be omega square plus 4 root over, that is equal to 1 by root 2. Let's solve this, right? It will become omega square plus 4 equals to 2. Omega square plus 4 equals to 2. Now squaring both sides. Right, something I am missing into this. Let me check what is I am missing. Okay, okay. Right, what I was missing is at omega equals to 0, what was the gain? Right, at omega equals to 0, at this should have been cleared, right? I got that. This should be for calculating the bandwidth. Man. So gain at omega equals to 0. That is 1 upon root over omega square plus 4. That is 1 by root 4. 1 by root 4, that means 1 by 2. And the value of the magnitude will be this by root 2 at the cutoff frequency. This by root 2 at the cutoff frequency. So 1 upon omega square plus 4, 1 by 2 by root 2. Now we can solve this. 1 by 2 by root 2. Correct. So that will be solved as one by 2 root 2 omega square plus 4 1 by 2 root 2, and that will be after squaring both sides what we are going to get 2 root 2 equals to root omega square plus 4. That means on squaring both sides I am going to get 4 into 2 8 omega square plus 4, that is resulting into omega square equal to 4, that is resulting into omega equals to 2 radian per second. So I can say that the omega open loop is 2 radian per second. Omega open loop is 2 radian per second. Right. Now I can take the closed loop example. The closed loop system. The closed loop system will be having Cs by Rs, that is Gs upon 1 plus Gs. So that is what 1 upon S plus 2 upon 1 plus 1 upon S plus 2. That is going to be simplified into 1 upon S plus 3. Right. Now the value of gain at omega equals to 0. Gain at omega equals to 0 will be 1 by 3, and the cutoff frequency will be magnitude of this gain, that is omega square by 9. That should be equal to 1 by 3 by root 2, that is 1 by 3 into root 2, squaring both sides, not what we will be having. 9 into 2, that is 18, equals to omega square plus 9. And if I solve it, omega square equals to 9. That means omega equals to 3 radian per second. Omega equals to 3 radian per second. That means omega CL is equals to 3 radian per second. Omega CL is equals to 3 radian per second. That means what is happening? The omega CL is more than omega OL. What is omega CL? Omega CL is open loop system bandwidth, and omega OL is closed loop system. Omega CL is closed loop system bandwidth, and omega OL is open loop system bandwidth. So closed loop system bandwidth is more as compared to open loop system bandwidth. That means what? That means simply that if we are going to find out the system frequency response, that is the magnitude of the input and output with respect to frequency, it is going to remain flat for more frequency in case of closed loop system, as compared to open loop system, because omega CL is higher than omega OL. That is the thing we have proved from this particular example. That is the thing we have proved. Right. So effect of feedback on bandwidth. Now in a nutshell, if we want to remember the important thing, what is the important thing? That due to feedback, the bandwidth increases. Due to feedback, the bandwidth increases. Due to feedback, the time constant decreases. These are all the effects that we have to remember while we are solving certain examples, certain problems. Effect of feedback on noise. Effect of feedback on noise, that is also called as disturbance. Noise or disturbance, that is also called as disturbance. So suppose we are having a disturbance NS, also called as DS, disturbance NS or DS. We are applying to an open loop system, such a kind of open loop system. So the open loop transfer function due to noise signal alone, if we are not assuming this, right, then open loop transfer function, that will be CS by NS equals to GB due to noise alone. Right, due to the disturbance alone, totally dependent on the value of the feedback forward path parameter GB. If forward path parameter changes, it increases, then the effect due to noise or effect due to disturbance also increases. Totally dependent onto this. Right. Now, if we are introducing in terms of feedback, consider a closed loop control system with noise signal as shown below. Consider a closed loop control system with noise signal as shown below. So what is that noise signal or disturbance signal? The disturbance signal or noise signal may be any kind of disturbance signal, right? DS. And now we want to find out the value of CS by NS. Due to the NS alone, that time the RS will be substituted as 0, and the feedback is now going to change. So our system will be replaced as, this system is going to become like this. This is GB. In the feedback, we will be having multiplication of GA into H, and that is going to remain minus. And here we are going to apply NS plus, and we are going to measure the CS. So the CS value will be, CS by NS will be GB upon 1 plus GA GB H. Correct. If it is 0, if it is 0, right? So that will be what? GB upon 1 plus GA GB H. And if H is considered to be unity, then it will be 1 upon GA GB. And if GA and GB is much, the product of GA and GB is much greater than 1, then we can say that the effect of disturbance is totally dependent on the value of what? The feedback path parameter. Right? GB is GB going to cancel out GA, the feedback path parameter. The higher the value of feedback path parameter, the effect of disturbance is going to be nullified. The effect of disturbance is going to be nullified. We can say that if it is H is present over there, for an example, we take the generalized equation. Right? We take the generalized equation. If GA GBH is much greater than 1, then CS by NS is equal to GB upon 1 plus GA GBH. That is, this one is going to be neglected. GB upon GA GBH. GB is GB cancelling. 1 upon GAH. So the product GAH is going to decide the effect of feedback, and it is going to reduce. The effect of feedback is going to reduce if the product GAH increases. Product GAH increases if suppose GA is constant because it was in the forward path. So if only H is increasing, that means the sensitivity or the performance of the sensor or performance of the measurement system is up to the mark. It is very accurate. Then the sensitivity corresponding to this particular disturbance is going to reduce manifolds. Sensitivity corresponding to this particular disturbance is reduced to be manifold. So we can say that, important note again, the disturbance effect can be minimized by increasing feedback path parameter value. Feedback path parameter value, right? By increasing the feedback path parameter value, the sensitivity towards the disturbances can be decreased, can be minimized, or disturbance effect can be minimized. Let's understand with a real example. As we have discussed in the earlier case also, we are talking about a temperature control system. An AC is placed inside a room maintaining the temperature, but somebody is continuously opening and closing the door. Then what should we do for continuously monitoring the change in room temperature? Obviously, we should have a temperature sensor such as which is able to detect very slight changes in the temperature, because if somebody is opening the door and closing the door again and again, there will be slight changes in the temperature, and these slight changes in the temperature should be measured as quickly as possible, right? If we are able to measure those slight changes in the temperature as quickly as possible, then we will be able to find out the error which is occurring due to disturbance, and then our controller will be going to take a necessary action according to it, and the output is again going to come to the desired value, right? That means the room temperature is going to again come to the actual value or the desired value, whatever we have set. So that is what we are saying, that our sensor must be very good, our measurement system must be very good to reduce the effect of disturbances in the control system. All right, any doubt to anyone? In the closed loop control system, the gain due to noise signal is decreased by a factor 1 plus GA/GBH, provided that the term 1 plus GA/GBH is greater than 1. One plus GA/GBH is greater than 1. Alright. Now let's come to the question. Now the party begins. Right. We have to understand the question. We have to apply the concept of feedback. Question number 1, which was a common GATE question for 2 marks. And it was asked for hello Krishna, you can join this free service. 2 marks, IN, EE and EC. Common question was asked in GATE 2013. Right. So before we go further, for Krishna, our new joinee, let me revise all the things what I have covered in this particular entire lecture. Quickly I am going to revise all the things. This lecture was on effect of feedback and feedback characteristics, effect of feedback on control system performance. So we discussed what are the types of feedback. There are 2 types of feedback, positive feedback and negative feedback. The control systems are actually classified according to 2 types of systems, open loop systems and closed loop systems. The open loop systems does not compare their output with the input, whereas the closed loop system compare their output with the input. This comparison is done in the form of feedback. So the feedback increases the accuracy of the output, and the feedback decreases the sensitivity towards the disturbances or towards the parameter variation. That's why the closed loop systems are preferable as compared to open loop system. We started from this particular point. I will complete the total course, my dear. Already I have entered into the 7th lecture. Started from last Monday. And now it is the 7th lecture I have conducted, and from tomorrow onwards I am going to start transient response analysis. In the next week I am going to discuss, this entire week from tomorrow Monday till Saturday or Sunday, I am going to cover the transient response analysis, steady state response analysis, the stability analysis using RH criteria. This thing I am going to cover in this entire week. So you are free, you are welcome to join this particular course, my dear Krishna. You can join this course, and the timing will remain same. Prerequisites required for control system. you should have a knowledge of transfer function only, the Laplace transform. You should have the knowledge of Laplace transform. That's the only prerequisites for control system. And you can at least you can go through my lecture number 2, 3 and 4 for doing problems on these upcoming classes. For doing problems on upcoming classes, you can go from through my lecture number 2, 3 and 4. You can just understand the concept of basic concept of control system, block diagram, signal flow graph. If you understand all those concepts, then you will be able to understand the remaining concepts, right? So just basic. I will not recommend you to go through the entire lecture, but some important initial discussion you can understand, you can learn from that. And the class notes are available on Unacademy GATE English Telegram channel, so you can have those class notes also from there. So you can just download those class notes and you can just go through those PPT. You will have the entire detail of the basics of control system. Okay, Krishna? So control system, open loop, closed loop, this thing we have discussed. Then we discussed what is called as a positive feedback. Positive feedback is called as regenerative feedback because the error signal is additive always. So it is going to reduce the gain, it is going to increase the gain, and the gain increase in gain may lead towards the oscillation that we have discussed, right? This can be implemented using a simple op-amp circuit. We understood that this type of op-amp is going to generate a square wave. That means the output is readily saturated to some positive value or readily saturated to some negative value. Therefore, positive feedback is not desirable. Therefore, the positive feedback is not desirable. And we also discussed about the negative feedback. What is the negative feedback? Negative feedback reduces the error between input signal RS and the feedback signal CS, right? And the system output CS. So due to negative feedback, the oscillations are decreases. The oscillations are still introduced, but introduced with small amount and not with a big amount. That's why the system is going to behave like a proper system due to negative feedback. So negative feedback is called as a degenerative feedback. Negative feedback is called as a degenerative feedback, and system can work like an amplifier. Using the positive feedback, the system works like an oscillator. So whenever we are going to design an oscillator, we can use the positive feedback, but if we want to design an amplifier, we want to design a control system, then we have to use the negative feedback because of its innumerous advantages. So the negative feedback are having the advantage, right? What? The negative feedback in amplifier and process control system is widespread because as a rule, negative feedback systems are more stable than positive feedback systems. This we have discussed in our entire lecture, how the effect of parameter variation is neglected using the negative feedback. Right now we have discussed about that. Effects of feedback, we discussed about that. Effect of feedback on sensitivity. So we discussed the discussion continued on to the sensitivity. Sensitivity towards the disturbances. In case of open loop system, it is 100%. We discussed that. Then for closed loop system, it is decreases by 1 upon 1 plus GSHS by the factor 1 upon 1 plus GSHS. For the closed loop system, the sensitivity with respect to feedback path parameter is dependent on the value of GS and HS. The control system is more sensitive to feedback path parameter variations. This is the important point. So these are the important points which I have written over here. This you can go through. Effect of feedback on stability, we discussed that also. That stability can be increased, can be decreased depending on the value of G and depending on the value of the omega. Because the G and H are the functions of omega. So we have to select the value of omega such that the system remains stable. We have to select the value of parameter gain K such that the system remains stable. This with one example we have proved that. We also discussed the effect of feedback on time constant. So I took one example. This is the open loop system. Open loop system time constant is 1 by 2, 0.5, and that is of closed loop system reduces, that is 1 by 3, that is 0.33, right? So due to feedback the time constant decreases. That we have concluded. Then effect of feedback on bandwidth. Open loop bandwidth was 2 radian per second for this particular system. The same system when incorporated into feedback, it is resulting into transfer function 1 upon s plus 3. And the closed loop bandwidth now 3 radian per second. It was 3 radian per second. So we proved that the open loop closed loop system bandwidth is more as compared to open loop system bandwidth. That means the range of frequency for which the output can remain flat can be increased for the closed loop system, and that's why the closed loop system are having more bandwidth as compared to open loop system, and we proved that. This is another effect of feedback. Due to feedback the bandwidth increases. So effect of feedback on noise, at last we discussed that if we are talking about the disturbance, right, for an open loop system, then it is totally dependent on the value of GB. If GB increases, then disturbance effect also increases. But if we are talking about a feedback system or a negative feedback system, then the disturbance effect is decreasing due to increase in GA and H. If we are increasing the GA and H suitably, then the disturbance effect can be decreased. So the disturbance effect can be minimized by increasing feedback path parameter value. This entire thing we have discussed. Okay. So now let's come to the problem. Sami, are you there in the lecture? And Krishna, are you there in the lecture? Nobody is replying. Okay, let's solve this problem. The open loop transfer function of a DC motor is given as omega s by VAS upon 10 upon 1 plus 10s. When connected in feedback as shown below, the approximate value of Ka that will reduce the time constant of the closed loop system by 100 times as compared to that of the open loop system is. It is talking about the feedback characteristics, and time constant reduces, right? We know that the time constant reduces. However, we can simply apply the concept of open loop and closed loop system here to solve this particular problem. Let's solve this particular problem. Okay. So how this output can be reduced, right? So first of all, let's find out the transfer function of the open loop system. So omega s upon VAS is 10 upon 1 plus 10s. So the time constant of open loop system, when I relate with standard transfer function, that is what? K upon 1 plus Ts. So the value of T is 10. The value of T is 10. Alright. Now let's determine the closed loop transfer function. The closed loop transfer function is ten Ka upon 1 plus 10s 1 plus 10 Ka upon 1 plus 10s. This is the closed loop transfer function T. If I solve this further, it is going to become 10 Ka upon 1 plus 10s plus 10 Ka. Alright, this is going to become, this can be solved further as 10 Ka upon if I take common 10 Ka, then 1 by 10 Ka plus 10 upon 10 Ka, or sorry, let's do it in a much better way. How this can be solved? 10 Ka upon transfer function 10s plus 1 plus 10 Ka. Right? So 1 plus 10 Ka can be taken as common. 10 K upon 1 plus 10 Ka, and that is going to become 1 plus 10 upon 1 plus 10 Ka into S. So this is the transfer function of closed loop. This is the time constant of the closed loop system. Say T dash. T dash is 10 upon 1 plus 10 Ka. And what is the condition given? The value of Ka that will reduce the time constant of closed loop system by 100 times as compared to that of the open loop system. That means what? T is equals to 100 times T dash. Now I can use this relationship. T is equals to 100 times T dash. Right. So T is what? 10. 100 into T dash. T dash is 10 upon 1 plus 10 Ka. Right. So 10 by 10, it is going to cancel out. Right. And it is going to become 1 by 100. So finally it is going to become 1 plus 10 Ka is equals to 100, or 10 K is equals to 99, or K is equals to 99 by 10, that is equals to 9.9. K is equals to 9.9. So the approximate value should be 10. This is our answer. This is our answer. Okay. It is clear to you? Is it clear to you? Or should I explain it once again? Is it clear to you? Krishna, Sami, Vignesh, Abhiram, that is how it can be solved. Very simple question. Right? We have to apply the concept of feedback only. Okay, let's go to the next one. Due to positive feedback, stability of system is increased but gain is reduced. Both stability and gain of system are increased. Both stability and gain of system are reduced. Stability of the system is reduced but gain is increased. So correct answer is T. The positive feedback incorporates oscillation. That's why the stability decreases. But gain is increased. Gain is increased. So correct answer is D. Right? Positive feedback introduces oscillations, hence stability reduces but gain increases because error is additive always. Error is additive always. The gain increases because the error is additive always. Next question. A unity feedback control system has a transfer function Ks plus B upon S square plus As plus B. The open loop transfer function of this system is. Any idea how this question can be solved? Very simple question. Right. The feedback control system transfer function has been given to us, that is Cs by Rs Ks plus B upon S square plus As plus B. This Cs by Rs is actually given by Gs upon 1 plus GSHs. This can be compared with the given value. Gs upon 1 plus GSHs is equal to Ks plus B upon S square plus As plus B. This can be compared with this. So, Gs upon 1 plus GSHs Ks plus B, sorry, this we have already written, right? Erase. So further, if I solve this, then it is going to become GS into S square plus AS plus B and 1 plus GS HS multiplied by KS plus B. If we solve it further, GS S square plus AS plus B GS HS sorry KS plus B into KS plus B into GSHS. Right? So this can be go on that side, other side. If we solve it further, GS S square plus AS plus B minus KS minus B into H of S, and that is equal to KS plus B right. It is clearly indicative that the feedback is unity, so I forgot to use that. Feedback is unity, so HS can be 1. HS can be simply put as 1. So what we will be having finally, GS is equal to S square plus AS plus B minus KS minus B is equal to KS plus B, right? And this can cancel out. This can cancel out, right? The B and B term is cancel out. So we will be having finally GS is equal to KS plus B upon S square plus S A minus K, right? That will be our answer. So S square plus AS minus KS. AS minus KS. AS minus KS, right? So A is the right option. A is the right option. This will be our answer. Alright, simple manipulations. Next question, again a theoretical one. It has been asked in 1 mark in EE. Right? GATE question hai. This is a GATE question. Feedback control systems are insensitive to both forward and feedback path parameter changes, less sensitive to feedback path parameter changes than to forward path parameter changes, less sensitive to forward path parameter changes than to the feedback path parameter changes, equally sensitive to forward path and feedback path parameter changes. So we have to remember the derivation what we have done, right? The sensitivity corresponding to STG was given as 1 plus GSHS. The sensitivity corresponding to STH is given as GSHS with a minus sign upon 1 plus GSHS. Right? This is the sensitivity given. So we can say that it is sensitive, less sensitive as compared to the open loop system, no doubt about that. But what about the parameter path parameter variations? So 1 upon 1 plus GSHS is the sensitivity corresponding to forward path parameter variation, and GSHS upon 1 plus GSHS is the sensitivity corresponding to feedback path parameter variation. Feedback path parameter variation. That means, that simply means that the control system is more sensitive to feedback path parameter variation, right? Less sensitive to forward path parameter variation than feedback path parameter variation. This is the right answer. This is the right answer, right, from this particular analysis. From this particular analysis and this particular analysis, where G represents the forward path parameter and H represents the feedback path parameter. H represents the feedback path parameter. Alright. Next and last question. As shown in the figure, a negative feedback system has an amplifier of gain 100 with plus minus 10% tolerance in the forward path and an attenuator of value 9 by 100 in the feedback path. Then the overall system gain is approximately. So for an example, if we are calculating the overall system gain, so it is C by R. C by R is G upon 1 plus GH, right? It's a negative feedback. So it is 100 upon 100 plus, 1 plus 100 into 9 by 100. 9 by 100 is going to become 9 plus 1, that is 10. 100 upon 10, that is going to become 10. So C by R actually is 10. But what is happening now? Now the tolerance, that we have to consider the two tolerance values, right? Let's consider the first tolerance value. C by R due to G is equals to 110. Let's compute that. So C by R 1, that is 1110 upon 1 plus 1110 into 9 by 100. What will be the value? Let's compute that. 1110 into 9 by 100, 9.9 plus 1, 1110 by answer, 10.091, 10.091, right? Now C by R due to, second case, C by R due to G is equals to 90, right? So C by R2, that is 90 upon 1 plus 90 into 9 by 100. 90 upon 1 plus 90 into 9 by 100. So 90 into 9 by 100, 8.1 plus 1, 9.1. 90 divided by 9.1, 9.89. 9.890. Now our actual gain should have been 10. Now the gain is 10.091 or it is 9.890. We can calculate the percentage tolerance in the overall gain, right? 9.89 minus 10 divided by 10 it's a 1% value, right? It's a 1% value, minus 1%, and 10.091 minus 10 divided by 10, it is also almost 1% value. So the correct answer can be A. That is our correct answer. A is our correct answer. It's a simple concept of calculation of error. Simple calculation error concept. So 10 plus minus 1%. 10 plus minus 1%. Right. Any doubt to anyone? So guys, you can join the Unacademy Combat Quiz. Today itself it was conducted for most of the branches on 21st of January. In every lecture's video link, you will be having this information of Unacademy Combat Quiz. In the next Unacademy Combat Quiz will be conducted, right? It is India's largest fortnightly competition for GATE. You can assess your GATE preparation in 65 minutes. Challenging and original GATE questions curated by the best educators. Take it live to compete with the best, right? Identify and improve your weak areas through detailed video solutions. And this is going to be live in the next fortnight. Okay. And if you earn a rank 1, then you are going to get 3-month GATE and ESE plus subscription. If you earn a rank 2 and 3, you are going to get 1 month GATE and ESE plus subscription free. And if you are having rank 4 to 100, you are going to earn 500 Amazon vouchers. Okay guys. So India's #1 studies channel, you can join any of these channels. Creatrix GATE E for EECIN, Unacademy GATE for AME, PI and XC, Unacademy GATE for Civil Engineering, Unacademy GATE Telugu, Unacademy SSC JE, Unacademy Computer Science, Unacademy GATE Questions, Electrical Junction, Unacademy Engineering Foundation, Engineering Pathshala. There are a lot of channels being operated by Unacademy on YouTube. You can join any of these channels. Guys, you can join my tomorrow's lecture from the timing 8:30 p.m. onwards, right? Tomorrow 8:30 p.m. onwards, I am going to start transient response analysis and some of the more questions on feedback we are going to do. Transient response analysis we are going to start from tomorrow. So guys, see you there. Transient response analysis part 1. The link of the video will be available in the Telegram channel. You can join that Telegram channel for the lecture notes. Right now, after this, the lecture notes will be provided to you. Okay. So if you have liked it, please like, share and subscribe, and please hit the bell icon to get all the notifications. So thank you very much guys. Thank you for patient listening. You can continue learning the control system. The whole syllabus will be covered, right? And you can learn this control system through me.